Hello everybody and welcome to my channel. I'm FlyLoader737 and today in this video we are going to have a look at the cockpit preparation of the Boeing 737. This is most likely how the 737 cockpit looks like this is how the cockpit of the 737 looks like at the beginning of the day, of the rotation of the working day. And at the moment we are in Denver airport. It's a beautiful morning, actually no clouds in the sky at all. The aircraft is being serviced for a flight to Boise in Idaho, and loading is going on. Still boarding has not started yet. So let's assume that the pilot monitoring has performed the walk around, and in the meantime the pilot flying is in the cockpit starting the cockpit preparation for the flight. Of course, due to the fact that the Boeing 737 is a multi-pilot aircraft, and in the simulator I am forced to work as a single pilot, many procedures that you will see are adapted to a single pilot environment, and of course do not constitute any form of training, and this video is just for entertainment and knowledge purpose. So let's get back into the cockpit. Let's go back into the cockpit and see how to start with the cockpit preparation. So up here in the overhead panel, the first officer has the duty of starting his or her flow, starting from the battery. As you can see, we already have the ground power connected, so we just put the battery on, pushing on the guard, and then we just check that everything is okay up here with landing gear lever down, flaps corresponding with the handle, so the handle is matching the indicator and vice versa. And then we go back again and we select the ground power on. Now the bus tie breaker has closed and the aircraft is powered up with 112 volts AC, which is converted into DC via the 3 transformer rectifiers unit that we have on board. And the battery is charged, is 29 volts at the moment in DC, so it's quite at its maximum capacity. So then the flow starts on the upper part of the overhead panel with the IRSs to nav, 7 minutes to the alignment, checking that the audio control panel number 3 is in flight selected. This is due to the fact that we don't want the audio control panel number 3 to go mad and interfere with our communication, or maybe the PA system, or with the interphone. So we just want it into flight, just to have the intercom active in case something goes wrong with the audio control panel number 3. And then some SOPs in some company report to do airspeed warning test and a stall warning test, some other doesn't. My company, for example, does not require to do this test, just the stall test warning is suggested. And then we go down here, checking the EEC that are in normal mode, oxygen sufficient for the flight. Usually we have a placard here that is reporting how much oxygen you need for flight time, how many crew members there are in the cockpit, and how high we're gonna fly. And many 737 have 2 jump seats in the cockpit, some of them just 1, so the table depends also on how many crew members there are in the cockpit. And then there should be a cockpit voice recorder here, or a flight data recorder here, so we should switch it on, forcing the auto system just to record also all the phases of the cockpit preparation as well. This kind of check is called rainbow check because it goes, you know, from the left side to the right side and then back to the left side of the upper part of the overhead panel. Then once this is completed, meanwhile the IRSs are in alignment, we start up here in the lower part of the overhead and we just scan the panel in columns from left to right, from the top to the bottom. So we start with the flight controls, got it. Low pressure light is normal at this situation, spoilers, got it. Yaw damper, we put it on and observe the light extinguishing. Navigation system to normal, display system to auto, and then we go to the fuel panel. Some companies require to carry out a crossfeed valve check before each flight. Some other says just to do the crossfeed valve check before an ETOPS flight, and some other does not. My company, for example, does not require to do a crossfeed check before each flight, just before ETOPS flight. And then we go down to check that the low pressure light is displayed in all the fuel pump that at the moment are off. Then up again here, cabin utility switch and IFE passenger seat on, drive light lit. This is normal due to the fact that the engine driven generator, the integrated drive, are not connected, or better, are not powered since the engine are shut down. And then the electrical power, we have ground power online, and just a note, the ground power available light is not dimmable. It is not influenced by the bright dim switch that we have here. For example, if we put the lights to dim and we go back to the overhead, as you can see, these have dimmed, but not this one. This matches the real behavior of the aircraft that does not dim this light. And it stays always on as long as the ground power is connected and the quality is good enough for the aircraft operation. And now we go down again, checking the Apu Egt, that is 0 at the moment since the Apu is not running. Some panel lights if we need, equipment cooling to normal, emergency exit light must be armed, so guarded. And then seatbelt sign, it depends on if refueling is in progress, we just leave the seatbelts off. If refueling is completed, we just put the fasten seatbelt sign on. And then we continue down and up again, window heat on, check the hydraulic pumps to have engine 1, engine 2 on, and the ELEC 2 and the ELEC 1 off. Doors, the moment we have these doors open, again up here in the air temperature panel, checking that the temperature selector knob are in a good range. During the first flight of the day, these knobs are usually set at 9 o'clock position to prevent very hot air to come into the air system for passengers, crew and cockpit crew. This is kind of limitation of the Boeing 737 air system, that at the first flight of the day, usually if these knobs are left in auto, they are just blowing out a lot of really hot air, about 60-65 degrees hot air, so it's much better and more comfortable to prevent this, having this knob at 9 o'clock position for the first flight of the day. Then after the takeoff, usually you are able to get somehow back to auto. And then the bleed panel, recirculation fan on, packs off, and then isolation valve actually doesn't it doesn't play any role if it is open or auto in this situation. I personally like to have it open on the ground, and then engine bleeds on and APU bleed off. Then in the pressurization panel we're gonna set the cruise altitude that we're gonna fly today, planned cruise altitude flight level 360, inbound Boise, and the landing elevation in Boise is about 2,850 feet that I have set it here. So it's well below 6,000 feet, where Boeing 737 needs a supplementary procedure for setting the landing elevation. This supplementary procedure says that if you land at an airport that has an elevation of more than 6,000 feet, you need to set 6,000 here during the cockpit preparation, and then you set the real landing elevation at the top of descent before starting the descent itself. And then pressurization mode selector to auto, some lights, yeah, the position steady lights are already on, and that's good enough. Then we go back and we power our EFBs, check the oxygen as well from here. So now we know that there is oxygen as well. We have checked it on the overhead up here, but now we know also that the oxygen is really there. And then some screens adjustment if we need some lights or screen brightness adjustment from down here. And then we set the Efus control panel. I personally use VOR view or VOR and ADF view if it's needed. I want the airport displayed, the flight path vector displayed. The altimeter is already set. 3008 is the altimeter setting for now in Denver, and we just set some kind of expected acceleration altitude. In my company's SOP, acceleration altitude is always, at least 99% of the time, 800 feet above the aerodrome level. So in this case, the aerodrome level or the aerodrome elevation is 5,380 feet or something like that, more or less. So we can estimate an acceleration altitude of about 6,180 feet. Yeah, coming up, and 6,180 feet, and this is a preliminary expectation. The real acceleration altitude is given during the performance calculation for departure and takeoff via the EFB. And just for info, these two knobs are well modeled in the Zibo because they are not turning, they are not spinning, but they are spring-loaded to the center. Both the minimum inner knob and the baro ref inner knob are spring-loaded to the center, and then they just need to be turned like a little bit to the left to decrease values and a little bit to the right to increase values. Then going to the right on the MCB, flight directors on. As you can see, the first flight director I have turned on as this light here, or in this case the light goes on the right side, and this is master. If I get closer, you see MA, master. It means that the first flight director that is switched on is the master. So the left flight director system is the master in this flight. So if the captain is pilot flying, this will be the master. If the first officer is pilot flying, this will be turned on first and will be the master. And during takeoff, for example, when we push the toga button, both master will illuminate. That is a requirement to have an auto throttle takeoff. Then what we are going to do is to adjust our course, heading, altitude according to the expected or received departure clearance, or PDC. And then we are just setting the auto brake to RTO, verifying that the light extinguishes, checking for oil quantity, yes we have, checking for hydraulic quantity, yes we have. And then we go down here, doing some fire tests, doing some bottle of fire extinguishing agent test, doing as well some cargo fire test. And in reality, what we are doing when we are carrying out these tests is to keep the belt sounding, and then with the other hand we just stop the bell, pressing the fire warning bell cutout switch here. And this is to be sure that the belt actually cuts out. Few radio adjustments if we need some radio aids for the departure, and adjusting the audio control panel as well with the radio that we want to talk, and these knobs here control the volume of the frequencies or the channels that we are listening to. Once this is done, most probably the boarding is going to start, and we just start to program the FMC. For this, stay tuned. I will be back with a specific video for programming the FMC. So I hope you enjoyed the video so far. Stay safe, and meet you soon on my channel. This is FlyLord737. Have a great day. See ya.